Here we have the 68, 95, 99.7 rule, also known as the empirical rule. And this is used for a normal bell-shaped distribution like you see below. And what it states is for large enough samples, you'll find out that 68% of the data will fall within one standard deviation of the mean, 95% within two standard deviations of the mean, and 99.7% lie within three standard deviations of the mean. You take any large enough population and many things in life become normalized. For example, let's say IQ scores have a mean of 100, a standard deviation of 15, and they follow a normalized distribution. So what we could do here is we go ahead and start by going right down the middle. The mean would be 100. And then what I would recommend doing is just add the standard deviation 3 times to the right. So add 15, add 15, add 15, and then subtract the standard deviation 3 times to the left. So subtract 15, and subtract 15. And then from there, you can go ahead and see that if I go one standard deviation above and below the mean, that'll capture the middle 68%. If I go two standard deviations above and below the mean, that will capture the middle 95%. And if I go three standard deviations above and below the mean, that will capture the middle 99.7%. So if they asked you this at all, you could go ahead and report, in this particular case, for IQ scores, 68% of the data would lie between 85 and 115. 95% would lie between 70 and 130. And 99.7% would lie between 55 and 145. Now that's great and all if it's a nice simple 68, 95, 99.7. However, if it gets any more complicated than a simple 1, 2, or 3, one thing I recommend doing is going ahead and actually drawing out a bell-shaped curve for each one of those and showing all the percentages. So what I mean is the following. So down the middle is 100. We're using the same setup here, and I would just go one above and one below, giving me 85 and 115, adding and subtracting 15. Then I'd have 68% in the middle. You would subtract 68 from 100 and get 32, divide by 2 and get 16% on each side. That's what's left over in the tails. Not only that, but down the middle, half of 68 is going to be 34 and 34%. So now you have all the combinations for before, after, and in between. And then you'd repeat this for 95 and 99.7. So add two standard deviations above, add 15, subtract 15, subtract 15, and the middle is 95%. Subtract from 100, you would get 5%. Divide by 2, it'd be 2.5 above and 2.5 below. And then divide 95 divided by 2 will give you 47.5%. If you want to go really extreme, for 3 standard deviations, 1, 2, 3, so add 15, add 15, add 15, you get 145. Subtract 15, subtract 15, subtract 15, you would get 55. And then from there in the middle, you'd have 99.7% in the middle. Subtract from 100, that's 0.3. Divide by 2, that's 0.15%. 0.15%. Cut this in half, and 99.7 divided by 2 will give you 49.85 on each side. 49.85, 49.85. And yeah, these percentages would hold true for 1, 2, and 3 standard deviations above and below the mean. So basically, if you're just dealing with the 68, 95, 99.7 rule, this is what you need to know for all the percentages. So they could ask anything. For example, what percent are over 130? Okay, well, 130 is over here. That's for 2 standard deviations, and above 130 would be 2.5%. What percent are between 70 and 115? So 70 is over here, and 115 is over here. So what you could do is you can go from 70 to 100, which is 47.5%, and then from 100 to 115, which is 34%, and you would add those together, giving you 81.5%. What is the top 2.5% cutoff? Okay, so for this one, to finish up, well, 2.5% is actually right here, and it cuts off at 130. So we're actually going backwards in that case, going from percent to the actual IQ value. And they could ask any combination, but basically it would be divided amongst these three. The only difference would be what is provided in the beginning as far as the mean and standard deviation. Lastly, they could ask you to go backwards to find the mean and to find the standard deviation with this last example here, where you could be given something like the average height of males in the US follows a normal distribution, and the middle 95% are between 60 and 76 inches. Find the mean height, find the standard deviation. So what do we have? Well, we don't know the mean. We're going 2 above and 2 below to get 60 to 76. Well, the mean's going to be in the middle. To find the middle, you just add and divide by 2. And that'll give you the mean overall. So 60 plus 76 divided by 2 will give you 68 inches would be the mean. So again, the answer for question 1 is going to be 68 inches. Now to find the standard deviation, one way to approach this is to realize, okay, if I went 2 above and 2 below, that's a total of 4 standard deviations across. So I would find the distance between them, 76 minus 60, and divide by 4, because again, it's 2 above and 2 below. You don't always divide by 4. It's because it's 95%. So take a moment and think about this. If it was 68%, you would divide by 2. If it was 95%, you divide by 4. If it's 99.7%, you divide by 6 if you want to use this process for those endpoints. So 76 minus 60 divided by 4 will give you a standard deviation of 4 inches. And there are several examples dealing with the empirical rule, also known as the 68, 95, 99.7 rule.